Hi, so in this video, I'm going to talk you through differentiation of equations in the form y is equal to x to the n. So this follows on from differentiation from first principles. So we'll begin with y is equal to x to the n. So the first thing we do is we multiply by the power. So what this means is we multiply this coefficient of x, which is 1x, we multiply this 1 by the power of n. So this becomes nx to the power of n. And then we subtract 1 from a power. So now we have dy by dx, gradient function, is nx, and when we take away 1 from this power, we're left with n minus 1. Okay, so this is the general form. So we'll work through the examples of question A. If we have x to the power of 5, we multiply by the power, so we multiply this 1 by this 5, and we get 5x. So dy by dx will be equal to 5x, and then we take away 1 from this power, so we're left with 5x to the power of 4. So for our next one, if we've got 4x squared, again, we multiply by the power, so we multiply the 2 by the 4, so dy by dx becomes 8x, and then we take away 1 from this power, and 2 take away 1 is 1, and then x to the power of 1 we write as x. So for question B, when y equals 4x squared, so this becomes 8x. Okay, so for part C, we have 3x squared plus 6x plus 8. So we work out each term in sequence. So we begin by multiplying the 2 by the 3, and we get dy by dx is equal to 6x. We take away 1 from this power, so it becomes 1, so we just have 6x. For the next term, we have x to the 1 times the 6, so this becomes 6. And then we take away 1 from this power, so it becomes 0. So all of this becomes 1. So we just leave it as 6x plus 6. And then for our next term, we have 8, which is the same as 8 times 1, or 8x to the 0. We multiply by the power. 8 times 0 is 0, and anything times 0 is 0. So this bit reduces to 0. So the gradient function is 6x plus 6. Part D, we can write the square root of x as x to the power of 1/2. So again, we multiply this 1 by the power, so it becomes 1/2 of x, and then we take away 1 from a power, so 1/2 take away 1 is minus 1/2, so it becomes 1/2 of x to the power of minus 1/2. Now we could also write this as 1 over 2 root x, which is exactly the same. Okay, let's try some more questions. So rather than having dy by dx, we can use function notation. And it's exactly the same idea. So for question A, we could write f of x. We need that as a power, and this is the same as x to the power of minus 1. So we multiply the 1 by the negative 1. So f dash of x becomes minus x, and then we take away 1 from this power, so it becomes minus 2. So minus x to a power of minus 2, which is the same as minus 1 over x squared. Okay, for part B, we have x to the power of 4 over 3 minus x to the power of minus 2 over 3. Well, we can multiply the 4 over 3 by the 1, so we get 4 over 3 x, and then take away 1 from this power, or take away 3/3, and we get 1/3. And then for the next term, we multiply the negative 1 by the negative 2/3, and we get positive 2/3 x. And again, we take away 1 from this power, so minus 3 over 3, and this becomes x to a power of minus 5 over 3. Now we can tidy this up. We can factorize out the division of 3 and x to the third. So we have the cube root of x over 3 multiplied by the 4 for this term, and then plus 2 x to the power of minus 2 for this term. Okay, and for part C, we have 3x times root of x, which is the same as 3x times x to the half, which we can write as 3 lots of x to the 3 over 2 plus 6x squared. So we'll multiply by the power, and we get f dash of x is equal to 9 over 2 x, taking away 1 from this power, leaves us with 1/2. For the next term, 2 times 6 is 12, and then we're taking away 1 from this power of 2, so we get 12x. Okay, let's try one more question. Okay, so in our final question, we've been asked to differentiate the square root of x plus 8 over x squared. So the first thing I'm going to do is to write this with powers. So we have y is equal to x to the 1/2 plus 8 times x to the power of minus 2. So now we can work out dy by dx. We'll multiply the 1 by this half, so we get 1/2 of x. We'll take away 1 from this power, so x to the power of minus 1/2. And then negative 2 times the 8 is minus 16. We'll take away 1 from this power, so x to the power of minus 3. And I can write this using fractions. So 1 over 2 root x minus 16 over x cubed. Now this is the gradient function, which allows us to find the gradient of a tangent to the curve when we know the x value. And for part B, we've been told the x value is 4. So to work out the gradient, when x equals 4, we're going to substitute x equals 4 into dy by dx. So we have 1 over 2 root 4 minus 16 over 4 cubed. And this becomes 0. So we know when x equals 4, we have a horizontal tangent to the curve. And I want to show you how to check this on a calculator. So if we use our calculator, we're going to the derivative function. We'll type in the equation y, so the square root of x plus 8 over x squared, and we'll set our x value to be 4. We can see the gradient is 0. Okay, thank you for watching, and I hope you found that useful. Thanks again, and take care.